Today, we're talking about one of the biggest shifts happening in technology, the electric car. Now, we all think of them as the future, right? But what if I told you they were actually a huge part of our past? We're going to dive into the incredible, surprising story of the electric vehicle's 100-year journey, all the way back to the top.
So, let's start with a quick question for you. When do you think the first really popular electric cars hit the streets? The 2010s? Maybe the early 2000s with the first hybrids? Go ahead, take a guess. The answer is probably not what you're thinking.
Believe it or not, the answer is the year 1900. Yeah, over a century ago. Electric cars weren't just some weird novelty. They were serious players. I mean, look at this chart. They actually outsold gasoline-powered cars. Back then, steam and electric vehicles were the ones dominating the market. Gasoline was the new kid on the block, the underdog.
So that brings up a pretty big question, right? If electric cars had such an amazing head start, why on earth did they basically vanish for almost 100 years? Let's dig in.
Well, it was kind of a perfect storm of problems. First, their range was only about 60 kilometers. That was totally fine for zipping around the city. But once people wanted to travel further, it just wasn't enough. And good luck finding a place to charge outside the city. There were hardly any power lines. Plus, the batteries themselves were expensive and didn't last very long. But the real nail in the coffin, that was Henry Ford's Model T. It was cheap, mass-produced, and the invention of the electric starter meant you didn't have to risk breaking your arm with a hand crank anymore. Suddenly, gasoline was cheap, easy, and it became king. And you know what's crazy? Some of these exact same challenges, range, charging, and battery cost, are still the main things we're trying to solve today.
So after nearly a century of being basically a ghost, the electric car finally got its second act. And its modern comeback story can really be told through two very different cars, each teaching a huge lesson.
First up, we have the cautionary tale. This futuristic-looking thing is the General Motors EV1 from the late 90s. It only existed because a California law forced car makers to build zero-emission vehicles. And guess what? The people who got to lease them absolutely fell in love with them. But GM wasn't making much money on them, and after a ton of lobbying from oil companies, that law got overturned. So what did GM do? They forcibly recalled every single EV1 from their drivers, people who adored these cars, and had them all taken to the desert and crushed. Just like that. A really tragic end for what could have been.
And don't just take my word for it. Years later, the CEO of GM at the time, Rick Wagoner, admitted it himself. He said that killing the EV1 was the single biggest mistake of his entire career. It was a massive strategic failure, a total lack of vision for where the world was heading.
But where GM failed, others saw an opportunity. In 2003, a little startup called Tesla was founded, and they learned a huge lesson from the EV1's failure. They knew you couldn't just make a niche compliance car, so they came up with this brilliant master plan. Step 1, build a ridiculously cool, high-performance, and yes, very expensive sports car. Why? To prove that electric cars could be awesome and desirable. Step 2, use the money from that to build a slightly more affordable, premium sedan. And finally, Step 3, use those profits to build a true mass-market car for everyone. This top-down strategy completely flipped the script.
Okay, so we've covered the wild history. Now, let's get into how these things actually work. What really makes an electric car so different from a gas-powered one? Well, the answer is a kind of beautiful, elegant simplicity.
The biggest difference isn't what's added, it's what's taken away. In an EV, you just get rid of the whole internal combustion engine, the exhaust pipe, the gas tank, the incredibly complex transmission, all of it. And in its place, you get a big battery pack, a simple electric motor, a charging port, and usually just a single-speed gearbox. Way fewer moving parts means way less that can break.
And this diagram really shows you that simplicity. You've got the three core parts, the big flat battery pack that sits along the floor of the car, the super compact electric motor, and the control unit, which is basically the brain. And you know, putting that heavy battery way down low gives the car an incredibly low center of gravity, which is why EVs often handle so well.
But the real mic drop moment is efficiency. An electric motor is incredible. It turns about 90 to 95% of its electrical energy into actual motion. Now compare that to a typical gasoline engine. You're lucky if you hit 30%. So where does the other 70% of the energy from gas go? It's just wasted as heat. This huge efficiency gap is probably the EV's single biggest advantage.
All right, let's zoom in on the most important, the most expensive, and definitely the most talked about part of any EV, the battery. It's truly both the heart of the vehicle and its biggest hurdle.
To really get the challenge here, you just have to look at the scale. On the left, that's a single lithium-ion battery cell. Right, it's not that much bigger than a regular AA battery. On the right, that's a full EV battery pack. It's made of thousands of those little cells all wired together. This whole thing can weigh over 500 kilograms. That massive pack is the secret to getting long range, but it's also where most of the car's weight and cost comes from.
Now, obviously, you can't just tape thousands of batteries together and hope for the best. You need a very sophisticated brain to manage it all, and that is the Battery Management System, or BMS. This thing is the unsung hero of every single EV. It's a powerful computer that is constantly watching over every single cell, checking its voltage, its temperature, making sure they all play nicely together to keep you safe and get the most performance and life out of the pack.
And why is that so important? Well, it turns out lithium-ion batteries are super picky about temperature. They really hate being too hot or too cold. So the BMS basically acts like a super smart thermostat, using heating and cooling systems to keep the whole battery pack in its ideal happy zone, somewhere between 15 and 35 degrees Celsius. This is absolutely essential for getting good performance, keeping the battery safe, and making sure it lasts for hundreds of thousands of kilometers.
Now for the really good news. That biggest hurdle, the cost, is coming down. And I mean it's coming down fast. Back in 2010, batteries cost a wild $1,100 per kilowatt hour. Today, that number has absolutely plummeted to around $156. The magic number everyone's watching for is $100 per kilowatt hour. That's the point where EVs are expected to cost the same as gas cars. And as you can see, we are getting incredibly close. This price drop is the single biggest thing fueling the EV revolution.
So, with costs dropping and the tech getting better every day, the future looks pretty electric. But are we there yet? What are the big challenges still standing in the way of EVs truly taking over?
The main roadblocks probably sound familiar. The high upfront price is still a barrier for a lot of people, even though that's changing. Then there's range anxiety, that fear in the back of your mind that you'll run out of juice. Charging times, even with a supercharger, are still a lot longer than a 3-minute stop at the gas station. And we definitely need a more reliable and widespread public charging network. Oh, and here's one you might not have heard of: tire wear. The instant power from electric motors is really tough on tires, and they can wear out in as little as 15,000 kilometers.
And of course, we have to talk about the big environmental question that always comes up. Every ad says zero emission, but is that the whole picture?
The honest answer is, it depends. The car itself, yeah, it has no tailpipe, it produces zero emissions while you're driving. But the real greenness of that car is tied directly to where its electricity comes from. An EV that you charge up with solar or wind power is incredibly clean. But if you're plugging it into a grid that's powered by a coal plant, you're really just moving the emissions from the car to the power plant. The bottom line is, the cleaner our energy grid gets, the cleaner our EVs become. But even with these hurdles, the market is just exploding with new options. A few years ago, you had maybe 1 or 2 choices. Now, just look at this quick snapshot. You've got everything from the practical Nissan Leaf to a long-range Hyundai Kona, a Tesla Model 3, or even a premium Jaguar I-Pace. The variety in range, style, and price is growing literally every single year.
And if you want to peek into the future, just look at Norway. Because of some really strong government incentives, about half, that's 50% of all new cars sold there are now fully electric. It's an amazing real-world example of how quickly things can change when policy really gets behind the transition.
So, from being outsold by steam cars in 1900 to being literally crushed and forgotten to being reborn with bold new ideas, the electric car has finally, truly completed its 100-year comeback. The momentum is here, and it's not stopping. Which really just leaves us all with one final, very personal question to think about.